Excellent. So given that, I am going to get started doing the documentation bash for TensorFlow 2.0. The motivation of this is to walk through the doc that I shared at a hackathon earlier this morning, and then also on a couple of listservs that we have for TensorFlow users, to walk through what the expectations are, and then to start looking at some of the API documentation that we have for TF 2.0, seeing where it stands, even if it's kind of spotty, and then making either issues or pull requests to resolve the problems that we have in the issues. So with that, let's take a look at the doc that I just created. So I'm going to do a screen share. Cool. Share. And there we go. Rad. Okay. So this is the TensorFlow 2.0 doc. It's an FAQ that walks through all of the ways that you can get involved with checking existing TensorFlow documentation. So you can look at this documentation quality. You can file an issue if it's in any way complete. You can modify the docstring or the corresponding markdown file. And then I also listed some additional links and blog posts that might be useful if you're considering, well, what is TensorFlow 2.0 actually? How is it different than the original TensorFlow? And we talked about that a little bit before. TensorFlow 2.0 has a focus on developer productivity. It's consolidated a lot of the API symbols into other modules. And it's also gotten rid of many symbols. So some of them are no longer in existence, especially if you're thinking about this particular module we had called contrib. But all of the rest of them should have complete, delightful API documentation, usage examples, and the like. So we're going to be checking to make sure that that is the case. And if it's not, we're going to be filing issues so that we will have a tangible plan to resolve them. So how do you assess API documentation quality? There is a link here to the Writing TensorFlow documentation post that we have on our website. It's a guide that was created by our docs team. They are phenomenal, and they were also pretty exhaustive about how you would go about doing code style, how you would do documentation style, how you would write about code. So the way that you would refer to inputs and to tensors and to file names, how you would sort of formulate that syntax in your markdown file, how C++ ops differ from Python ops, and then also some examples of what docstring should look like. So a fun fact about most of our TensorFlow documentation, and let me just show you. This as a quick example. So most of our TensorFlow documentation is generated. It's not markdown files that have been created and sort of placed in various locations on GitHub. If you click on one of these guys, so for example, let's take a look at identity. It tells you, and this is a poor example of an API symbol documentation. So just, oh well. But it tells you precisely where the op is defined. So it's defined in a place called Python ops arrayops.py. And if we bounce over to GitHub, and we jump to the TensorFlow repo, so TensorFlow-TensorFlow, and then we take a look at arrayops.py. We should find a file. Python ops arrayops. It might be easier to just go hunt for it. TensorFlow Python ops array ops. There we go. That shows you precisely everything that is being used to generate this doc. So you see here a doc string. It says returns a tensor with the same shape and contents as input. Arguments are a tensor, name is a name for the operation, and that is optional. And that is what we have reflected in our doc. So if I wanted to change this guy right here, all I would have to do is change this guy right there. And the other nice thing about sort of being directed towards the code whenever you look at the API docs is that you can see all the nitty-gritty stuff that's being done to sort of architect these operations, right? And this, so for example, this is a phenomenal example of a docstring. Too bad that they didn't go into that level of detail for the op itself. So there is a lot of great information. There is a lot of great information in the code. It's just a matter of kind of hunting it down and putting it in a place where it would be a little bit more readily exposed to the user, right? It's also really cool that you get to see to-do items for some of my coworkers and for some of the contributors to the TensorFlow library. That's pretty nice. But yeah, so that's the background, right? And we've discussed that some of the ops are generated by Python. Some of the ops, though, so for example, let me take a look. I was checking out a math operation today, a little bit earlier. So let's look at arc cosine. So this guy says defined and generated file, Python ops gen math ops. And if we go back to that repo that we were checking out before, so Python ops, there is no file called gen math ops. And that's because this is being created. It's not an explicit Python file. And that would be a much sort of crunchier doc modification to make. So I highly suggest that if you're just thinking about getting involved with modifying documentation, modifying docstrings and code for TensorFlow, maybe don't start with the docs that are generated. Start with the ones that are explicitly located in Python files. And that would be nifty. This guy is also poorly documented, though. So it looks like we have some work cut out for us tonight. Rad. Okay, so heading back to this doc, we've learned what writing good documentation looks like from this Writing TensorFlow documentation guide. We have been directed to refer to fields in the TensorFlow docs tasks tracker, and that is this guy. So this is an open document. Anybody can use it, anybody can look at it, anybody can sort of make comments to modify it. And what it is intended to be is a way to cycle through each API symbol that we have in the TensorFlow 2.0 documentation to say whether or not the links are correct, the description is clear, the usage example exists, the parameters are all defined and they exist and they're the same parameters that are created in the code. The returns are defined, the errors, the value errors and type errors and all that good stuff are listed and defined and sort of understandable, straightforward. And it has visuals if applicable. So what does that mean? That means that if we're talking about arc cosine, it would probably be cool to have like a little graph of what arc cosine actually looks like. That seems like it would be a good idea. And it also has a link to the GitHub issue once you've looked over all of these various fields and you've decided whether or not this API symbol meets your expectations. So I did this first one here. And obviously aggregation method does not have correct links. It doesn't have a clear description, no usage example, no parameters defined, no returns defined, no raises listed and defined, and the visuals aren't there. So I've created a GitHub issue and let's go take a look at what that seems to be. I listed the existing URL creating the issue or containing the issue rather. The correct links. So the original link was faulty, and this one makes a little bit more sense. I mentioned that the description wasn't as clear as it could be. There was no usage example, there were no parameters, or the parameters were poorly defined and also not formatted. So we had some code in there that was not appropriately formatted. The returns were not defined, the errors raised and listed weren't defined, and there weren't any visuals. So that was a poor example of an API simple doc. Going down, if you're unsure as to what a clear description would be, here's an example. It's opinionated about when to use it. It makes sense when you read it. So use this when your inputs are in string or integer format and you have a vocabulary file that maps each value to an integer ID. By default, out of vocabulary values are ignored. It tells you when to use additional items. And it also tells you what kind of input dictionary you should have and what you should do if it falls into this particular tensor category. So that is a great sort of clear description from tf.feature column, categorical column with vocabulary file. That makes sense. A usage example, what would that look like? And a usage example is sort of a complete, fully contained way that you could run, a code sample that you could run, and it would provide some output. And this is an okay usage example, mostly because some of the values just aren't there. But another ideal usage example would be if we bounce back over to tf.math.acosine for arc cosine, being able to say, all right, well, what is the arc cosine of 0? And then to show the response back from that. So just having a code sample, an example that you can run, and it would give you back some sort of response. And ideally, it would be, if there were any sort of variations for these guys, you would be able to express that as well. So a single value, maybe a collection of values, and so on. Next question, are the parameters defined? And so a great example would be here from linear model. It goes through and it talks about the features, the feature columns, the units, sparse combiners. It gives examples of what the features should look like, and very, very detailed sort of information about what this particular symbol is looking for in order to make a correct assessment. Returns defined, returns a tensor, which represents predictions, logics of a linear model, tells you about the sort of the data type, and it tells you about the shape. Value errors raised and defined. There could be a variety of errors, but ideally they would all kind of be human friendly and not give you any sort of surprises. And visuals if applicable. So if a visual is included, does it make sense? If there's no visual, is there an opportunity to create one? And here's an example from tf.gather. They're just kind of explaining what the process is doing, and then also sort of making notes about how this would be impacted by differing architectures. Then once all of that's done, once you've made the assessment that yes, this is good or no, this is bad, it's time to make a GitHub issue, and you would create it in the format that I showed above. And if you have any questions, you can contact me anytime at webpage@google.com. Let's check to see if any folks have arrived. So I see a couple. That's awesome. Hello, everyone. I am screenceptioning, but also talking about how to work on some of these issues that we have for TensorFlow. And so let me backtrack a little bit. Making modifications to the symbols docstrings, providing examples, providing even part of this, right? So like if you wanted to create like a small plot or a graphic that describes what a symbol is doing, but you didn't necessarily want to go in and give a clear description or a usage example, that's fine too. Any small modification that you can make is wonderful. And even just telling us that a symbol is borked is phenomenal too, because there's no way that we would ever fix it or know to fix it if somebody didn't say that the symbol was actually wrong. So given that, we've looked at the doc, we've looked at an example GitHub issue, we've looked at the tracker. Let's take, and so we've got math cosine, right? Like TensorFlow.math.arc cosine. Let's go through this guy and see how he stands for the issues that we were describing, the different parameters of what would be useful. So does he have a clear description? Not at all. It says computes a cos of x element-wise. It doesn't tell us what a cos is. It doesn't tell us what x would be. Well, I guess it does in the arguments, but it doesn't tell us in the description, which is troubling. And it says element-wise, but that's so I assume x has more than one element. Rad. But like I said, description could use some work. Tell us what this operation is actually doing. Tell us why it would be useful. And you can obviously see that it's useful to a lot of people if it's been included in this many versions. So tf.math. Let me control F. tf.math.acos. There you go. So correct links, we'll get to that in a second. Clear description, no, not at all. Usage example, does it have one of those guys? No, I see no usage example. What about the link? There is not even, well, I suppose there's this guy. But that's interesting. So there's no link, which means that I suppose the links are correct. There's no usage example. But I would like to know if this particular example is generated, where exactly is that generation occurring? So I'm going to create another column called notes. Make that bold. And that I'm going to say, go back to where it was. I'm going to say no link to files that would be used to generate this symbol. And even though it's probably a stretch to ask for those, I think that it would be incredibly useful for anybody who wanted to modify it instead of having to hunt down whatever C code is used to create the dang thing, to just be able to click a link and to be automatically taken there. So parameters, are the parameters defined? A tensor must be one of the following types, correct? And then a name for the operation, which is optional. So this seems to make sense. Tells me it should be a tensor. It assumes previous knowledge of knowing what a tensor is. And it tells me what kind of types it should be. So let's say that the parameters are defined. The returns, are the returns defined? Returns a tensor with the same shape as x. That sounds pretty nifty. The errors raised and listed. You see any? Nope, I see no errors, so that's problematic. I'm actually kind of curious, like what happens whenever we would raise an error. There are no visuals, though those could be very, very useful. And so cool. It looks like there are some problems with this symbol that should be tackled by a human. And let's take a look at this. So if I go to a Collab Notebook, let's try so a new Python 3 notebook. And we learn all of the naming conventions of every data scientist, right? Is tf.nightly, tf.nightly 2.0 preview. I think that is correct. But we learned the naming conventions of every data scientist, which is untitled 8.ipynb. You just keep going for as many ones as you have days in the week, right? And keep. I think all of us have like some sort of, shameful untitled 102.ipynb. But what I'm doing here is I'm just downloading the latest version of TensorFlow, so TensorFlow 2.0. This is a Collab notebook available at Google from collab.research.google.com. Anybody can use Collab, but if you're using a version without cost, then the environments recycle. So you usually have to reset all of the packages that you would want to have added. So I'm going to import TensorFlow as TF. I'm going to check versions to make sure that it is the version that I want. And it tells me that yes, this is the developer version of TensorFlow 2.0. Rad. Okay, so we're going to look at tf.math.acosine. Gives a little helpful hint that I should have a tensor and that it should be some sort of type. So let's give it that. Okay, cool. So it tells us this is a float 32. That's the value. It tells us the shape. Perfect. And then if we wanted to take a look at those errors that I was talking about before, so what is I don't know. A good string to have today. I was talking about anamorphs today. So we're gonna input the string anamorphs. Or actually, to prove that I know what's up with anamorph, Aximili, I'm probably spelling this wrong. Escarouth. It's still, that's, I probably, Andalite, but there you, oh, Jesus. Oh, sorry. That is a terrible error message. Cool. So, okay. So I just, I put in a string rather than a numeric value to this math operation. So obviously it shouldn't be giving me back anything of interest, but ideally it wouldn't give me back could not find valid device for node, and then all kernels registered. So this is something that would be useful to highlight in an error message, that it could be a little bit more user friendly in terms of the output it provides whenever I provide an argument that isn't quite expected. So let's see what it looks like whenever I insert something else. So let's try true. So it's Boolean. Again, should not be anything of interest. But it also has kind of a borked error message. And we can see in the traceback precisely where that would be located. So it seems like it's happening with XLA in this eager execute file that is generated. So it doesn't exist. Excellent. So this is useful. I mean, I know it doesn't kind of look like it's useful, but it is, in that we have a math operation. It does what it's supposed to do. when you give it a value that it expects. So one of those B float 16s, halves float 32s, and 32 and 64, whatever. But whenever it doesn't give you what it's expecting, the verbiage is a little bit obfuscated. So that's something that we can put in our error message, or our issue that we file, is that some of the errors could be a little bit better explained. Excellent. So with that, let's go ahead and file our error. Let's not just talk about it. So we go to TensorFlow, we go to Issues, we go to New Issue, we go to Documentation Issue. You can feel free to ignore most of this information. So TensorFlow version is useful. Doc link is useful. So let's copy paste this guy. And let's describe it. And then it says towards the bottom, we welcome contributions by users. Will you be able to update, submit a PR using the doc style guide to fix the issue? I shall certainly try. And then please make sure to documentation issue. Excellent. So we have 2.0 API docs. Let's say tf.math .acosine. You can see I used similar naming conventions for aggregation method. Use the correct system information, the correct doc link. And then now let's describe the documentation issue. And let's do it using those columns that we discussed before. So correct links are correct, but remember, we wanted to be able to say the file is generated, or the documentation for tf.math.acosine is generated as that guy, Python ops genmathops.py. It would be excellent to have a link to the files that a user could modify to resolve issues with the documentation listed here instead. Cool. And then back to this guy, so clear description. This symbol could use a clear description example. Let's take a look at what acosine looks like in the SciPy ecosystem. So, or I guess in NumPy. So it talks about it being a multi-valued function, trigonometric inverse of cosine element-wise, and then it talks about sort of the mathematical formula for that. So if y is the cosine of x, then x equals arc cosine of y. It goes into a lot of detail about parameters and what's returned. It gives references, usage examples, and then also has a plot. I wonder, but SciPy, yeah, let's just provide a link to this as something that would be a good, use a clear a clear description, usage examples, and example visuals. And example visuals. A great template to model this on could be, and this was numpy.arccosine. Cool. So we've listed that the symbol could use a clear description, that it could use some usage examples, and then now to talk about the errors. The errors that are created when an unexpected value is entered is used you just say obfuscated errors with unexpected arguments. Example, strings, booleans, and even like, I bet you it would be with plain ints as well. So if I do tf.math.acos0, yeah, it's there's still kind of wonky errors. So I am going to make sure to list these guys in the issue. Booleans and even just some examples are shared below. And let's see what this looks like. Make it prettier formatting. Okay. Documentation for generated from would be excellent to have a link to the files. Is created from a generated file. It would be excellent to have a link to the files that are used to generate and math.ops.py, so a user could modify make modifications quickly without having to search through TensorFlow. Math.acosine could use a clear description, usage examples, and example visuals. A template to model this on could be users also experience obfuscated errors from unexpected arguments. Example strings, booleans, and even just ints. Examples are shown below. Preview. So I guess it's not Python. Maybe it's Bash. Nope. Regardless, that still looks fine. And we welcome contributions by users. Would you be able to submit a PR to fix this issue? I shall certainly try. Cool. So I think that that's most of the useful things that I could insert into this issue. I wonder. So eager execute.py. I wonder if I could hunt down the doc that's being used to, or the file that's being used to generate this error, just to make it a little bit easier on folks. So eager execute. And it should be a folder name. Execute.c. So this looks like it could be execute.cc. And then what was the error message again? Could not find. Could not. Yep, there we go. Cool. Let me make sure that's the only. Could not find valid. Yep. That's the guy. And then copy. Not copy line, but copy permalink and put that in the issue as well. The file used to generate this error is located here. Most math operations, all tf.math.star operations and their derivatives and their the operations they influence would experience these same obfuscated errors. Let's see if I can find an example. So linspace would be one, linspace. And what linspace does is it asks me for a start value, a stop, and then kind of a step, and then a name, but that's optional. So let me just do integers for this, not using floats, using just integer values. So 1, 5, 5, 2, just 1. Enter, and yeah, so it throws the same thing. So tf.linspace would be an example. So operations eg linspace experience these same obfuscated errors. Cool. So we've got the TensorFlow version. We've got the link to the documentation. We're describing the issue. So we're talking about how it's created from a generated file, and it would be great to have the files that create the generated files. So if we wanted to make modifications, we could. It's talked about how it doesn't have a clear description or usage examples or example visuals, and something that we could base that on. Talked about how there are obfuscated error messages. Excellent. This looks like it is ready. So I'm going to assign some labels. You don't have to worry about this. And I'm going to assign it to this project. And I'm going to submit it. And it has been submitted. And once that's done, copy paste, stick it in the doc, click enter. And since I'm going to try to fix it myself, I'm going to assign myself. If you don't have time or you don't have interest in resolving some of the issues in the symbol, you would just leave this component blank. So that's it. That's everything that you would need to do in order to make modifications to TensorFlow docs. Perfect. So with that, I think this session, this live stream session, stop sharing, is over. And also the room got very unexpectedly dark because it is nighttime in the Bay Area. I don't know if it's nighttime wherever you are, but it is certainly nighttime here. Awesome. Thank you. This was a blast. So have a great night. If you have any interest, I'll place links in the doc and the links to the doc into the spreadsheet, and then we can go from there. Bye, guys.